Dear colleagues and guests, allow me to consider open the meeting of the Dissertation Council for the defense of Mikhail Ryazantsev dissertation for the degree of Doctor of Chemical Sciences in the scientific specialty 020009, High Energy Chemistry, on the topic the development of computational models and methods for the rational design of photoactivated molecular systems based on organic molecules and proteins. According to the order of St. Petersburg State University from the 7th of August 2020, me, Nikolaevich Timofeyev, Doctor of Physical and Mathematical Sciences, Professor, Head of the Department of Optics, St. Petersburg State University, was appointed the chairman of this Dissertation Council, and by the same order the members of the Dissertation Council were approved. Let me introduce them. Viktorov Alexey Ismailovich, Doctor of Chemical Sciences, Associate Professor, Head of the Department of Physical Chemistry, St. Petersburg State University. Vasin Andrei Vladimirovich, Doctor of Biological Sciences, Professor of High School of Biomedical Systems and Technologies, Acting Director of the Institute of Biomedical Systems and Technologies, Peter the Great, St. Petersburg Polytechnic University. Bazarnova Yulia Genrikhovna, Doctor of Technical Sciences, Professor, Director of High School of Biotechnologies and Food Production, Peter the Great, St. Petersburg Polytechnic University. Skvartsov Alexey Nikolaevich, he is in the remote interactive mode, Doctor of Biological Sciences, Professor of Institute of Physics, Nanotechnologies and Telecommunications, St. Petersburg, Peter the Great, St. Petersburg Polytechnic University. Can you hear us? Yes. Tseulianov Dmitry Ivanovich, Doctor of Physical and Mathematical Sciences, Professor, Director of Scientific Center, CIMAN, the Faculty of Electronics and Telecommunications, Technical University, Moldova. Dmitry Ivanovich, can you see and hear us? Everything is okay. Thank you very much. Our applicant is also here with us, Ryazantsev Mikhail Nikolaevich. And also in the remote interactive mode, there is a scientific advisor, Tveryanovich Yuri Stanislavovich, Doctor of Chemical Sciences, Professor, Head of the Department of Laser Chemistry and Laser Material Science, St. Petersburg State University. Yuri Stanislavovich, I can see you and hear you. Me too. To improve the quality of communication, I ask you, dear colleagues, to turn off your microphones, but do not forget to turn them on when you are given the floor. I also inform you that audio and video recording of our meeting is being conducted, as well as a live broadcast on the St. Petersburg University website. Simultaneous interpretation from Russian into English and from English into Russian is also provided. At this time, an email address is posted on the live broadcast of the meeting of the Dissertation Council, where during the meeting all listeners can express their opinions and send questions to the applicant online concerning his dissertation and current scientific discussion of his speech. These questions will be forwarded to me by the technical services, and I will voice them during the discussion. Questions must be related to the applicant's presentation and the content of his dissertation, and the name, position, and the place of work of the author of the question must be indicated. Questions that are not related to the scientific discussion, to the discussion of the dissertation, to the text and assessment of the dissertation itself will not be voiced. In accordance with the procedure for awarding the academic degree of Candidate of Sciences, academic degree of Doctor of Sciences at St. Petersburg State University, approved by local regulations of St. Petersburg State University, hereinafter the procedure, a meeting of the Dissertation Council is considered eligible if at least 2/3 of the approved membership of the Council takes part in its work, but not less than 4 people. Our Dissertation Council consists of 6 people. All of them are present, including 2 in the remote interactive mode. All members of the Dissertation Council and the applicant are provided with audio-visual contact. Thus, there is a quorum. The procedure of today's meeting of the Dissertation Council with a total Duration of approximately 3 hours is the following, but according to our experience, we will try to finish earlier. A brief report of the chairman of the documents submitted by the applicant for a scientific degree and their compliance with the established requirements, 5 minutes. A short presentation by the applicant for a scientific degree reflecting the main points of his research, approximately 20 minutes, but dear candidate, please take your time. Number 3, questions to the applicant strictly according to his report, approximately 3 minutes per questions. Answers of the applicant, no more than 10 minutes for all questions. Speeches of all members of the Dissertation Council in turn with the assessment of the dissertation research, with a summary of their positions, with questions and suggestions for the dissertation, about 10 minutes per speaker. The speech of the chairman with his review, about 10 minutes. Answers of the applicant for the scientific degree to questions, comments of the members of the Dissertation Council, no more than 20 minutes. This point is usually placed after the speeches of the board members, but I think it's better to answer after each speaker. Number 8, open discussion, speeches at the request of those present at the defense of the dissertation of persons with a summary of their positions and with specific questions and proposals for the dissertation strictly on the topic of the research. All interested persons are requested to register in the registration form and completely introduce themselves. A presentation by the chairman of questions addressed to the applicant, which came in order to discuss his speech, and scientific discussion on the broadcast of the meeting of the Dissertation Council on the university website. Answers of the applicant, speech of the scientific advisor of the applicant, no more than 3 minutes. Discussion of the results of the defense by the members of the Dissertation Council before the open vote, during which the sound of the broadcast is muted, about 5 minutes, but we will do it if it is necessary. Then open roll call, counting of votes by the chairman of the Dissertation Council with the entry of the results into the minutes of the meeting, making a decision on awarding or not awarding the academic degree, concluding remarks of the applicant, no more than 2 minutes. Dear colleagues, are there any questions or objections to this regulation? No questions or objections. If there are no objections, I will proceed to the implementation of the rules of the meeting, but before, please turn off the sound of your mobile phones. Thank you for understanding. So, the first point of our meeting, the dissertation of Ryazantsev Mikhail Nikolaevich for the degree of the Doctor of Chemical Sciences in the scientific specialty 020009 High Energy Chemistry on the topic the development of computational models and methods for the rational design of photoactivated molecular systems based on organic molecules and proteins. The dissertation was accepted for the defense by the academic secretary on the 7th of August 2020. Ryazantsev wrote his dissertation research on the basis of St. Petersburg State University. The scientific advisor is Dviranovich, a Doctor of Chemical Sciences, Professor, Head of the Department of Laser Chemistry and Laser Materials Science, St. Petersburg State University. He is here with us. The number of publications of the applicant in which the main scientific results of the dissertation are stated according to the list presented, 15 works. In peer-reviewed scientific publications from the list approved by the Ministry of Education and Science of the Russian Federation, no publications. There are 14 publications in Web of Science and Scopus. The applicant submitted to the scientific secretary a complete package of documents for acceptance, for consideration and defense of the thesis. All documents correspond to Clause 12 of Section 3 of the procedure. All the documents submitted by the applicant on the information I received from the curator meet the requirements and are stored in the applicant certification file. The copies are held by the employee of the department for maintenance the activities of dissertation councils, who is here in the hall. Before giving the floor to the applicant, dear board members, do you have general questions to the applicant? And if there is a necessity to announce and consider the entire list of documents? No questions. Nikolaevich, the floor is yours. Thank you. Let me start my presentation. The work is devoted to the development of computational models and methods for the rational design of photoactivated molecular systems. For the design of any molecular system, including photoactivated molecular systems, it is necessary to pass the following stages. It is necessary to verify this model with the help of the experiment. Then it can be used for the purpose of molecular design. Any verification of computational model can't give the answer to the question about the reliability. This question, there can be situations when the model can give successful results for one systems and unsuccessful results for other systems, and it is necessary to conduct many experiments. In my work, any model which is offered will be tested with the help of the experiments, and if there is not enough experimental data, we will try to obtain them. If we speak about the molecular design, there are two approaches. We can change functional groups, their position in the skeleton of molecules. Here you can see other benzol compounds. They're used as photo switches. Spectral properties can be variated in broad scope. These are properties of necessary design of photochemical property. When we work with biomolecules, there is an additional design. It is the change of amino acid sequence of protein, the substitution of one amino acids with others, and the diversity of these amino acids together with cofactors can define the methods of proteins. Here there is an example, classical example of the rhodopsin family, which perform various functions and in all the kingdoms of nature. It is seen that by changing the amino acid sequence of the protein, the spectral properties can be varied over a wide range. It is necessary to mention two approaches to the design: rational design, detailed understanding of molecular mechanisms. In this case, we can conduct rational design. The separate case of rational design is biogenetical design, when we study high effective molecules, enzymes, photochemical, biological molecules, and on the basis of the study of the mechanisms, we try to reproduce this property on the basis of low molecular compounds. We can use the methods of automatic screening with the use of a mechanism of artificial intelligence, a lot of screenings, and the presence of reliable computational model is necessary. In modern chemistry, the main concept used to create computational models is the potential and energy surface. On the surface of potential energy, it is necessary to search for stationary points. those which correspond minimum transitional states. And for excitated states, it is necessary to localize the space of conic intersections. And if we speak about the transition states from different spine multiplicity, the space of intercommunicational conversion is taken into account. It is possible if the Schrödinger equation can be calculated with Gaussian gradient. In order to calculate the gradient of Gaussian, and we can use the methods of molecular approaches, and if the system is of a large size, it is a usual state for protein systems. Reactional centers can't be described by simple approximation. It is necessary to use hybrid methods. In this case, hybrid methods of which combines quantum mechanics. What is necessary to say before we formulate the purpose of the research? A lot of quantum chemical and molecular mechanical methods are developed. The development started at the end of 1980s, and since 1990s and the beginning of 2000s, we have received a lot of studies within the frames of this work. We developed a lot of models for proteins of rhodopsins, which are one of the most simple membrane proteins which are widespread in the nature. Apart from that, in order to make design methods, to develop design methods, it is necessary to develop automated methods. Today, there are a few automated methods they are developing. We need to search transitional methods by guess. It is very difficult, and it does not allow to find transitional states. The aim of the research to develop models and methods for rational designs protein systems on the basis of molecules, direct models for the research of specific types of proteins and photoactuators, and the development of computational models which allow to obtain new results. Let me start from the first provision. We conducted affinated labels. It is used as a detector. It is attached to ligand. Also, some fluorescent or radiochemical label is also attached to ligand. After X-ray, ligand is bonded with a receptor by covalent cooperation. It is a widespread approach, and there are chemical labels. We offered the label on the basis of computational modeling. The series of modeling of different labels was used, and only one was offered, and the synthesis was offered, and photochemical properties were studied and investigated. The label which was investigated, it is shown in the slide. Verification of the model was conducted for the calculation of spectrum. There are data which show that calculated and usual spectrum correlate. They are reliable results. We calculated the way of photochemical reaction and defined that photoactivation comes through serious conic intersections which we localized, and comes to reaction products. And reaction product is singlet nitrine with a closed shell. Singlet nitrine will allow us to use it as a label, as a reactional capable compound. Our preliminary calculations showed this system allows to receive singlet nitrine with the shell. The data were tested with the method of spectroscopy of high resolution, and the results were tested in the Journal of American Science. And the next provision, our works on the development of models for biological molecules. In this case, we speak about rhodopsins. Rhodopsins are widespread in nature membrane proteins. At the moment, about 10,000 rhodopsins have been identified in all three kingdoms of living nature. They perform many functions, from sensor functions, from vision, photosynthesis, phototaxis, and many of them are not known. 10,000 are verified, and about 40 crystallographic structures were deciphered. In order to calculate photochemistry of rhodopsins, it is necessary to make molecular mechanic and quantum mechanic models. It is necessary to begin with a cofactor, to choose methods, protonated Schiff base, three-dimensional structure of protein. It can be received on the methods of comparative modeling. Their crystallization is very difficult, and there is a limited number of crystallographic structures. Rhodopsins have been studied. Up to now, there are 40 structures. We started these investigations more than 10 years ago. There were 8 or 9 crystallographic structures, and crystallography usually can't see water molecules. The optimization of protein structure should be conducted, and spectrum absorption should be calculated. Then we should define whether this model can allow to reproduce spectrum properties. At the beginning, we received spectrum in this specific phase. It was received in 2006 with the help of special amplifiers. We made necessary calculations, used methodology which allows to reproduce spectrum, which can be seen in the slide. After that, we created our crystallographic our model on the basis of crystallographic structure and calculated the spectrum of crystallographic model. We received spectrum with the gradient of 20 nanometers. And recently, we showed that our methodology on crystallographic structures works. We took 40 structures and showed how our methodology works, the dependence on different used methods of water forecast and different constructing methods of crystallographic structure. And today our crystallographic structure, which we receive on the basis of our model, allows to reproduce the spectrum with the accuracy of 20 nanometers. We showed that our model was verified for visual rhodopsin. We speak about visual rhodopsin, BK. This visual rhodopsin is very well investigated. The model, using the model of this rhodopsin, we define the mechanism. We show that the process comes through conic intersection, which we localized, and it explains very quick reaction. Reaction takes about several seconds. We also defined the mechanism. We outlined modes which define quantum outputs, the reaction of photoisomerization. The results were published in Journal of American Chemical Society. We used the models for the definition of rhodopsins. The tasks in 1995 there was an experiment which showed that after nanochlorine absorptions the shift was 9 nanometers, and experimentators found out that chlorine ion was localized in a different place which had been expected according to spectrum, and the shift should be 100 nanometers rather than 30 nanometers, and these proteins should work in a narrow scope because it is activated and deactivated. The mechanism was defined by us. Iron chlorine gives the shift about 100 nanometers. Reorganization of other, first of all, polar amino acids leads to further shifts of spectrums to the red side, and explains experimental shift, and the result were published in the Journal of American Chemical Society. Then, as I have already mentioned, we investigated about 10,000 proteins. They were deciphered. The situation won't change in the near future, and it is necessary to be able to produce calculation models. This opportunity was investigated by us, and if we choose methods correctly, we can create calculation models which allow us to receive about 20 or 30 nanometers of deviation. The results were published in the Journal of American Chemical Society. These structures were used for the explanation of visual adaptation of calmars and visual adaptation of squids. The depth was about 20 to 360 meters. Although the mechanism of visual adaptation of squid was investigated, our modeling showed that although the mechanism of tuning in this case is different. I'm not going to be too detailed. I wanted to show how computational models can be used for the solution of biological problems. If you know the rhodopsin's photochemistry, it is the switcher with a quick selectivity. If we take rhodopsin cofactor and transmit it into solvent, these properties are lost. And the next step was to conduct biometric design, which will mimicize the properties of rhodopsins but without protein environment. It was necessary to mimic the surface of potential energy. We conducted modeling of this series of offered structures. They were chosen on the basis of the structures which can synthesize on the basis of our calculations, which showed that there are non-barrier ways of transition into conic intersections. Two switches were offered, and their properties were studied, and the high speed of photomerization was proved. Quantum output was very low, about 25-30%. It can't reach quantum output, necessary quantum output, and this approves quantum hypothesis that ultra-quick reaction is necessary for this quantum output. It is necessary for high quantum output, but the results were published in Journal of American Chemical Society in 2 articles for different switchers. And now let me turn to the next step. It is the development of different algorithm. The method offered Satoshi Maeda and Akeji Murakoma were took as a basis, and I used them during my investigation, and I faced this with this methodology. It allows us to find transitional stages and study chemical relations on the basis of reagents. The main idea of the method is it is necessary to move forward, move up on the way which defines the deviations from it. Has a strict physical explanation, but in order to realize this method, a lot of mathematical problems should be solved. Maeda method was used in its program complex. Modification of this method were made by us. The main problem of this method that Hessian in each point should be recalculation. It is very costly, and we offered the methods which allowed updating, and updating methods were found out which allowed to make the updating process quicker, and the program can be used for the systems of a larger size. This project is realized in our program code, which has the certification of registration, patent of the Russian Federation. We introduced this code and other methods of limitations. It is necessary to investigate high excitated states. We need limitations on the energy, and initial version of code did not allow us to do it, and it allows us to use different constraints, and it allows us to make the search for the reactions ways quicker. We offered to use the methods for the search for the chemistry in excitated states, starting with and here I would like to introduce two examples. Together with Satoshi Mayet, we conducted a global search. It showed that the method is very reliable and can find many transition states. There can be 10,000 of transition states, and it is them, and they are obtained semi-empirical. In quantum chemistry, the quality of these models can be improved. The results were published in the Journal of Physical Chemistry and Chemical Physics. Also, we used this method for DNA intercalator. Experimentally, it was known that there are two DNA intercalator with different quantum output. One output is 0.002%, another one has 29%. To study quantum chemistry without searching methods and search for transition states, it is very difficult, but with the help of these methods we found out conic intersections and transition states and minimum starting from quantum point, and it is clearly seen that the barrier is increasing and quantum output of reaction decreases and fluorescence increases. I have presented to you the main stages of our research, these methods, and further development of these methods. Today, computational chemistry has a new stage, and in the next 20 years there will be serious breakthrough in the modeling methods. The algorithm of machine learning is being implemented. Different methods of search for automated search for the way of reaction. The development of our models is necessary for them. The development of the methods of artificial intelligence can be effective. It is widely used experimentally. In computational terms, it is less used for the reason that there is lack of reliable computational models. Nevertheless, for the calculations of spectrum property of rhodopsins, we can conduct preliminary investigations. It is possible. The main provisions are listed. They can be found in the list in the text of the dissertation. I'm pressed for time. That's all for now. Mikhail Nikolaevich, thank you very much. Are there any questions? Dear colleagues, which are in remote interactive mode, are there any questions? Mikhail Nikolaevich, I have one question. You say that there are algorithms for the search of improved ways of chemical reactions. Let me return to the slides. If we compare with the methods which realized by Satoshi Mayet, it is a breakthrough method. And today let us focus on what we have done. First, we created new methods of updating Hessian, and the calculations of secondary matrices of derivatives is very difficult. Different methods of updating Hessian are used. The updating on the basis of calculated gradients. This method successfully works in minimization, but in terms of optimization of the sphere, the situation is different. We offered these updates. Next, we introduced constraints. Such constraints there are two types of constraints which often used in optimization of limitations. When we come to some subspace, the second method is the use of the Lagrange multiplier. Only projection methods were realized. They are often used in quantum chemistry. It allows to use different constraints simultaneously. Energetic constraints, the energy of excitated state and the energy of low state were the same, and it allows to receive the space of conic intersections, and we can search for minimum and maximums in these spaces. And the third one, there were no mathematical changes. We applied this for photochemistry and offered specific mechanism. How can we act to start from Nikolaevich point and find conic intersections and transition states. These methods works for relatively simple systems. If these are systems in one stage, it is a very reliable method. In case of two stages, we have to work here, but in terms of, despite problems, these methods are the best today. Are there any other questions? Dmitry Ivanovich? Do you have a question? Yes, I have some questions, but they concern my review. If it is necessary to list them now. Dmitry Ivanovich, according to the procedure of our meeting, we will listen to each board member, and your questions will be voiced later. Are there any other questions, strictly according to the report? Mikhail Nikolaevich, I have one more question. Tell me, please. The work is very extensive. It can... what about practical research? First of all, these programs are used now, and we use them for the search for chemical reactions, for the ways of chemical reactions. And also, as for fluorescent label, it is used, and experimentators show that it works. As for our models for rhodopsins, because of huge importance of these molecules, first of all, in optogenetics, it is a main tool. These models are very important for the development of rhodopsins with a specific spectrum properties. We try to use kinetic algorithm. We have got preliminary results. They are not included into the dissertation. They will be presented further. we use genetic algorithm, automatic construction of our models, and we receive the shift into red sphere, and we try to make the synthesis of our compounds and see how it works. And please show me slide 27. In your report, you used two types of indicators, red and blue. This is a transform of red and blue. Yes, I received the answer to my question. One more question of discussive character. The deviations of calculation values and experimental values, how can this deviation and the modern methods of quantum chemistry does not have better results for that. The problem is for small systems we can use high level methods and achieve practically complete output cluster methods, but for systems of such size, these are the best methods. 20 nanometers, it is the best correlation with the experiments. It is the uniqueness of your results. Yes, these are successful results from the point of view of calculations. Quantum chemistry always gives approximate values. If you use the methods of bonded clusters, the situation is different. In the chemistry of excitated states, the situation is a different correlation and so on, and it is always problem. Why do quantum chemistry methods work? The difference is reproduced much better, and when we use design, this difference is more accurate, and thanks to that, such models give reliable results. The main thing is to choose the best methods. What are the experiments concerning such methods of modeling for other molecular systems? Methods of modeling which we use automatically for any molecular system, as any person who deals with modeling, he deals with general methods of development and with the methods of applications for specific systems. It is necessary to choose the specific method for specific system, and it's not a trivial task. Technically complicated investigations are necessary. Are you satisfied with the answer? Yes, I am. Are there any other questions? I have a short question in this slide which describes the prospects of the development of the methods. The development of the method of artificial intelligence, including genetic algorithm. Please explain what do you mean by that? The genetic algorithm is called by mathematicians, is one of subsection of the development of methods of artificial intelligence, along with the neuron networks. Well, I view that from the point of view of biology. This is terminology, one of the methods of artificial intelligence, along with neuron networks and so on. Are you satisfied? Are there any other questions? If there are no questions, distinguished board members, do you have any remarks concerning the work? And now the reviews. We have got one external review from Professor Massimo Alivucci from a laboratory of
Green State University, USA. Отзыв достаточно короткий, поэтому я его, наверное, зачитаю. Вопросов в нем нет, поэтому...
Let me read out the review. It is very short. It is the information about the advantages and
computational modeling of rhodopsins. I recognize the relevance and the high quality of Dr. Ryazantsev's research work. The results of his research have been reported in a number of high-level publications and constitute a relevant contribution to the entire field of computational photochemistry. I believe that the results of his work are not only highly valuable for the research field focusing on rhodopsins, but are also of importance for the general field of photobiology and for their potential application in the presently expanding area of optogenetics. Yours sincerely, Professor Massimo Alivucci. Вопросов в отзыве нет, поэтому отвечать не надо. Но, как я уже сказал...
No questions in the review, and he highly appreciates your dissertation. There are no more external reviews, there are no online questions, and now let us turn to official discussion. We have to listen to the remarks of the board members. So all the reviews were published on St. Petersburg University website. Dear board members, please focus on the most important moments of your reviews, and at the end, please make a conclusion whether our candidate deserves the degree or not. Alexey Ismailovich. Nikolai Alexandrovich, I can't hear you well. Can you hear me? Yes? I can't hear you well. Can you hear me? Now it's better. Thank you for the floor given to me. I am a young board member. This is my second time. For 20 years I have been working in doctoral council on physical chemistry, and my review is specific, and the actuality of tasks, modeling of photoactivated conversions of complex biomolecules is a complicated task, and it can't be solved nowadays within the frames of strict quantum mechanics. That's why the fact that the author focuses on the models based on combinations of different approaches of quantum mechanics, molecular dynamics is valid, while he describes mechanical processes. But although these new computational models are the basis for all the investigations of our candidate, the novelty of the work does not finish by this methodological part, but it is defined by the results of the application of these models for the description of biologically important photosensitive compounds. Our author defines new molecular mechanisms of photoactivated processes for the range of systems and finds new biometrical molecular switch. And the reliability of the results and the validity of the conclusions of the work is provided by the use of well-developed quantochemical approaches and methods of molecular mechanics and molecular dynamics with the use of reliable force fields and also correlation of the results. Practical significance is very high, and it is defined by the fact that the author offers a program, a software package. It can be used for the development of photosensors, photoactuators, and affinity labels. The dignity of the work is the strict logical structure of the text, but the report of the candidate was different. It resembled mosaics, and as a result, each chapter is preceded by the formulation of specific purpose and the list of the results. Then the author describes the results and of applications of the model and molecular mechanisms, their correlation with experiments. After the review chapter 1, chapter 2 and 7, in each chapter there is a new physical and chemical information, new molecular mechanism, the application for different complex, for most part rhodopsins and other photoactivated compounds and processes. And it is very significant from the point of view of physical chemistry. And chapter 8 stands apart, the last chapter. It is devoted to the developed methodology, and this chapter is a fundamental, is a basis for modeling of other systems described in the dissertation. In the basis of this methodology, the author makes contributions into modification and updating of calculation schemes and algorithm. The author offers the methods of automated modeling of the ways of photochemical reactions from Frank Condon point to reaction products. They include the search for transition and intermediary states of reaction on the surface of potential energy of the main and excitated state. Our candidate formulated new methods of Hessian renewal when the transition between local systems of hyperspherical coordinates is taken into account. The process, the most significant is the fact that all the methods which are offered, they are realized as software packages. There is certificate of registration, official bulletin of Federal Intellectual Property Service. Then a lot of work conducted by our author is very significant. The results of work are published in international journals with high ratings. There are some questions and remarks. Number one, I would like to see the evaluations of the reliability and demonstrations of work capacity of theoretical methods of the research concerning global topology of the surfaces of potential energy, possible ways and kinetics of reactions for the most simple model systems. Unfortunately, this question is not discussed in the dissertation. Nevertheless, the author discussed them in his works. Number 2, the same picture is repeated in the text twice. Pictures 4.1 and 4.7 are identical. There are some roughness of presentation. For example, mimic. In the Russian language, there are no such a verb. In the Russian language, we have verb imitate. For example, vectors of differences of gradients and vibronic. Despite these remarks, I am sure that our candidate deserves the doctoral degree. The dissertation on the topic, the development of computational models and methods for the rational design of photoactivated molecular systems based on organic molecules and proteins, conforms with the requirements of the order from the 1st of September 2016, procedure on awarding degrees at St. Petersburg State University. Our candidate deserves the degree, doctoral degree, in speciality 020009, chemistry of higher energies. Point 11 was not violated by our candidate. I agree with the remarks. I included one additional slide which shows how it works on the simplest systems. This software complex needs further development and improvement. New tests should be conducted. There are new examples. It is eternal process. I agree with your remarks. Alexei Ismailovich, are you satisfied? Thank you. Andrei Vladimirovich, the floor is yours. The novelty of the information and actuality of the research defines whether the dissertation is successful or not. The actuality is defined on the one hand that these systems are actively applied in biology, chemistry for controlling and monitoring of different processes, and the methods of the study of the design are actively studied, and among these methods computational modeling plays the great role. We understand that computer modeling is impossible without experimental studies, and the dissertation represents successfully all the models. They were tested and proved on biological examples, biomolecules, and the examples from different spheres. As for the novelty of the dissertation, different computational models were presented, and if we look at the list of publications presented by our candidates, 14 articles in Web of Science and Scopus proves the quality of the research of our candidate. And the certificate of registration of the program for electronic computing machine, and so on. And when I got acquainted with the text of the dissertation, I had no questions. One question: in your work, you show a good correlation of the maximum of protein absorption with experimental value as a matrix for the evaluation for the quality of forecast structure, and to what extent such metrics for one system can they be applied to other systems. As for the formal part, the dissertation of Ryazantsev, Mikhail Nikolaevich, on the topic the development of computational models and methods for the rational design of photoactivated molecular systems based on organic molecules and proteins, conforms with the requirements procedure on awarding degrees at St. Petersburg State University, and our candidate deserves the degree Doctor of Chemical Sciences, specialization 020009, high energy chemistry. Point 11 was not violated by our candidate. Andrei Vladimirovich, thank you very much. Michael Nikolaevich, please answer the question. We have limited number of excitated states of different nature, and if this method works for one excitated state, it should be used for another state, and if the answer is no, and at this stage of the development for such huge subsystems, we should consider experiments, and the level it is not which all the works should be conducted simultaneously. If we speak about the first question, the use of the calculation with the maximum of absorption for the quality of forecasted structure, we tried to investigate this question. If the spectrum of constructed model conforms with calculated and obtained in the experiment, we can use the result. It does not mean that it is the right model. It means that it can be used and tested further. We found out several models where we reproduce the spectrum, but they are different. And if the spectrum is not reproduced, the model can fail. The deviation will be 100 nanometers in this case. Yulia Genrikhovna, the floor is yours. The problematics of the research is actively developing interdisciplinary sphere for monitoring and management and control of molecular processes. As for novelty and practical significance of the work, these properties were used for defining of the first stage of rhodopsin. The author verified the models. The works were tested in 14 scientific works. I would like to highlight that the computational models which were developed, they were tested, and also these developed models and methods are of high practical significance. They can be used in nanotechnologies, biotechnologies, and so on. As for the report, our candidates demonstrated deep knowledge. Some remarks. Chapter 2 presents the information on the influence of reorganization of polar and charged amino acids of halodopsin on the spectrum of protein absorption. And did you conduct systematic research of the influence of polar and charged amino acids of protein on spectral characteristics of rhodopsin? Is there some connection of spectral shift with the presence of polar and charged substitutes of amino acids with their position? And I think that the dissertation of our candidates on the topic, the development of computational models and methods for the rational design of photoactivated molecular systems based on organic molecules and proteins, conforms with the requirements of the conforms with the order from the 1st of September 2016 procedure on awarding academic degrees at St. Petersburg State University, and our candidate deserves the doctoral degree in the specialty 02001 high energy chemistry. Point 11 was not violated. And as for your remarks, we conducted similar research. We made the graphs which show the shift of the charge, and on their basis we tried to build models, and experimentators ask these pictures from us, but the theoreticians say that this is obvious. There is nothing new from theoretical point of view, but from the practical point of view we can build simplest model. Thank you. Yulia Genrikhovna, are you satisfied? Alexei Nikolaevich, the floor is yours. I appreciate this work positively. There were a lot to say about actuality and novelty. Let me say a few words. As a user of different algorithms, this work is characterized in comparison to other works on computational chemistry. It is characterized by the fact that it comes together with the experiment. As for mechanical calculations, I think that most part of calculations in this field, it is a competition of different calculations. It's not so interesting. This work is always based on the experiment, and it is the advantage of the research. I can say that there is lack of successful and qualitative work in this field. Most part of methods are connected with calculations, the third sign, and at the end of this work we receive software package which can be used for different purposes. I want to highlight, as our candidate has mentioned, rhodopsins is one of the most popular objects of modern biotechnology. They're used not only in potential optogenetical applications, they are viewed as very prospective objects of biophotonics, optoelectronics, due to their high chemical resistance for external actions, influences, and this topic is very actual, and that's why the work is very actual. I want to say that some information, some data in the report, from the report, were not reflected in the text of the dissertation. I have some questions. In the work, you used the algorithm of forecasting water molecules in protein, but they are absent in the molecules of crystal structure. Why? Can you explain this fact? Vice versa, there are cases. The second question, the choice of calculation experiments. Here you use mean modulus of gradient. Why don't you use mean square deviation, for example? Pearson statistics, their level of significance, and other indicators which are connected with the graphs. And as for cost of resources of your calculations, computational methods, how much time does they take, and so on. And as for terminology, I'm not going to ask questions. My colleagues have mentioned them. And official conclusion, the dissertation of Mikhail Nikolaevich on the topic the development of computational models and methods for the rational design of photoactivated molecular systems based on organic molecules and proteins conforms with main requirements of the order from the 1st of September 2016, number 6821/1, procedure on awarding academic degrees at St. Petersburg State University, and our candidate, Ryazantsev Mikhail Nikolaevich, deserves the degree of Doctor of Chemical Sciences in Speciality 020009. High Energy Chemistry. Point 11 was not violated by the candidates. Thank you very much. Alexey Nikolaevich, thank you very much. Michael Nikolaevich, please answer the question. Let me start with the first question, crystallographic structure and the resolution of water for membrane proteins. The quality of the structure is very low. It is very difficult to crystallize them. The resolution is very weak. Very often the water can't be seen there. It is the first problem. The second problem is that the crystallographic structure. It is a discussive question. In order to see water, it is necessary to make it non-liable, and if any water is more liable, crystallographers can see it. And as usual in biology, there is additional difficulty. It is very complex system. That's why we receive vague models and complex models. As for statistics, I agree with your remark. It was one of the work hundreds of calculations were made on the basis of 40 crystallographic structures. We made sampling, and I agree with you because I understand that you deal with calculations of such kind. The statistics should be recycled better. We should have been more serious and use different approaches. The defining of correlations, the extent of correlation, and so on. The third question, the time of calculation. It is a time-consuming process, and now all the calculations are on the basis of clusters, high parallel, the calculations of one model in order to receive spectrum of rhodopsins. 24 processes. It takes several days. Several years ago, it took 2 weeks. And you know that now modern technologies, they are more successful. Alexei Nikolaevich, are you satisfied with the answers? Dmitry Ivanovich, the floor is yours. No voice in the microphone. Can you hear me? Yes, we can. Dmitry Ivanovich, the floor is yours. Dear colleagues, photoactivated molecular systems have always attracted the attention of physics, chemists, biologists, and they are applied in photopharmacology, biosensors, and the dissertation of Mikhail Nikolaevich is devoted to modeling of the design of such systems, and it is the sequence of the huge progress of the technologies and its penetration in many spheres, especially into the sphere of molecular biology. The aim of the work is the development of computational models and methods for rational design of photoactivated molecular systems on the basis of low molecular compounds in protein molecules. The tasks are the following: the development and verification of the models for the calculations of spectral properties of photosensitive proteins, rhodopsins, on the basis of the crystallographic structure as well as the amino acid sequence. The calculations of main characteristics of surfaces of potential energy of main and excitated states of visual rhodopsin and butyrrhodopsin. The construction of computational model of the first stage of the process of their photoactivation, design of low molecular photoactivated switches imitating photochemical properties of rhodopsins, and the development of algorithm for automatic modeling of photochemical reactions from Frank Kondonov's point to reaction products, and the creation of program code. It led to the interesting results which were presented by the author. These results are original and makes the contribution into photochemistry, photobiology, and they are proved by the cited scientific publications, more than 650 publications. In the materials of the dissertations are published in the privileged journals and were presented at international conferences. And the practical significance It is proved by the opportunity to use the computational models and mechanism of protein photoactivation, rhodopsins, for the design of new molecular tools for optogenetic research, as well as for the development of new pharmacological medication for the diagnostics and treatment of ophthalmic diseases, and methodological quality of the research. The aim and task of the research are very accurate, hybrid. The methods of computational chemistry, methods for the research of the surfaces of potential energy, hybrid, quantum and mechanical methods were used. Bibliographical list is very comprehensive. The results, the interval is 85 years, and the most part of the literary resources of the last decade. The recommendations are formulated in the conclusion of the dissertation. The list of the main results, the development of molecular tools, the overall assessment of the dissertation is positive. I will be brief concerning my questions and remarks. Number one, why biometrical and molecular switches which you offer demonstrate the speed of isomerization at the same time span as for isomerization of rhodopsin? Number two, how did you interpret measured biometrical molecular switches at 5-IZG2 aminopyridine spectrum of non-stationary absorption? Number three, and while constructing computational model of photoactivation of DNA intercalated, the method is quite new, and I have the question about the sphere of application of this method. As for the remarks, as for the report of the candidates, I have no questions, but it was very difficult to understand in the distance. I think that the dissertation of Ryazantsev, Mikhail, Nikolaevich, the development of computational models and methods for the rational design of photoactivated molecular systems based on organic molecules and proteins conforms with the main requirements of the order St. Petersburg State University, and our candidate Ryazantsev Mikhail Nikolaevich deserves the degree of the Doctor of Chemical Sciences on specialization 020009, Chemistry of High Energies. Thank you. That's all. Dmitry Ivanovich, thank you very much. Question 1. Why do switches which must imitate the work of rhodopsin don't reproduce quantum output? We can't answer this question. We are conducting the research. The modulation of quantum outputs requires the study of a large number of trajectories, and at the same time the used methodologies are very expensive. Nevertheless, we use the models which are smaller than rhodopsins, and we are trying to develop such a switch we reached super quick isomerization and coherence, which is viewed in rhodopsin, and one more molecule is created. It was done after I left the group, and this molecule, in this we can observe coherence in this molecule. The question is open, and I hope that over several years we will be able to answer this question. The second question: how did we interpret the spectrums? On the basis of calculated data, we modeled all the intermediary states. On the basis of the calculations of reaction waves, they were compared with experimental spectrums of spectroscopy of high resolution. This is one more reason it is very difficult to interpret such difficult things. And question number 3. The application of that very method, it is limited. First of all, by the methodology used for the calculations of intermediary states, and the method when we are far from Franko-Donowskaya point. Such methods are very costly. It will be defined by the choice of the method, and we have such methods. We can use it and find transition states. The second limitation is connected with the methodology. We will face with such a problem in case of complex reactions. There will be new difficulties. Mikhail Nikolaevich, thank you very much. Dmitry Ivanovich, are you satisfied with the answers? And now it is my turn. If it is positive, I will be as brief as possible. I liked the work, and first of all, this autumn there are two works of cross-disciplinary character. Medicine and biology was the previous work. Here we deal with the chemistry, and of course it brings huge problems for our candidates. Also, practically he managed to become a specialist in connecting fields. And as for new fields for the research, the work of Mikhail Nikolaevich is of cross-disciplinary character, and a wide range of new and interesting results was obtained. The work is actual, and I am not going to repeat the main provisions of my report. I have got 3 questions. Let me focus on them. Number 1, you show that the main contribution into the process of photoisomerization of retinal chromophore in visual rhodopsin is provided by the modes. Are there any experimental data which can prove this? facts. Question 2, pictures 1.3 and 8.4, they are the same. I think that text distance made you repeat the pictures. And question 3, stylistical remark. Design. The word design is used very often by the author. It would be better to use the word development or creation, but my remarks don't spoil overall positive impression from the dissertation. It is a completed work. Theoretical provisions were developed and they can be qualified as a scientific achievement. And let me read out standard phrase. I'm not going to read it as a whole. I am sure that Ryazantsev Mikhail Nikolaevich deserves the degree of the Doctor of Chemical Sciences on specialization 020009. Chemistry of high energies, point 11 of the order was not violated by the candidate. Mikhail Nikolaevich, please answer my question. I agree with your remarks. It is very important to pay attention to the accuracy of the language, especially academic language. And as for the question concerning whether we can see the interaction between main mode of skeleton fluctuations and the shift of hydrogen atoms, we have got such experiments, and it was shown that the phase of mode full of fluctuations. No voice? I am satisfied with the answer. Are there any other questions? Online questions? No questions. I would like to give the floor to the scientific advisor, Professor Tverinovich Yuri Stanislavovich. Yuri Stanislavovich, can you hear us? I hope you also hear me. As Nikolai Alexandrovich kindly agreed to allow me to read out my review, I decided to make informal speech. Apparently, I'm the only board member who has the opportunity to observe the work of Mikhail Nikolaevich in the scientific field, but also in the fields connected with that. You will understand what I mean. I have got a question. What is the characteristic feature which can explain the whole pedagogical activity of Mikhail Nikolaevich? It is globality and complex character of the approach to solve all the problems. Let us take scientific activity. Very often we get acquainted with scientific research which have both theoretical and experimental parts. In most cases, it is a fact that theoretical methods of calculations are used and then a certain experiment is conducted. In this case, we face with a complex approach. Methods, algorithm of quantum and chemical calculations are created by the author, then they're used in calculations, and then the work creates corresponding calculation programs and uses compounds with unique photochemical properties. And this complex character is a characteristic of the whole activity of Mikhail Nikolaevich. His scientific team includes representatives of different organizations, and it concerns not only the employees but also students, not only from St. Petersburg State University. When we speak about pedagogical activity of Mikhail Nikolaevich, it is not surprising that he delivers a lot of lectures on his thematics, and in this respect Mikhail Nikolaevich has a global position. He created a special master's program on fundamental applied aspects of nanomaterials and nanotechnologies, and he develops this training program, master's program. And I would like to focus on this personal trait of Mikhail Nikolaevich and professional trait. Yuri Stanislavovich, thank you very much. I think the words of Yuri Stanislavovich are better than what is written in his review. Scientific advisor of potential Doctor of Sciences has to characterize the applicant, and in this respect it seems to me that Yuri Stanislavovich gave us the full information not only about the scientific side of the work of Mikhail Nikolaevich, but also about other aspects of his activity. And I'm not going to read out the review of Yuri Stanislavovich. Thank you. As we are working in the remote interactive work mode, dear colleagues, especially those who are online, did you see and hear us? These are technical questions. Were there any problems with the connection? I didn't have any problems. Alexei Nikolaevich, what about you? There were no problems. Everything was clear. And now we have to switch to the discussion of the work. Do we need a 5-minute break in order to discuss today's procedure and make a decision? There is no such a necessity. Let us discuss everything just now. I'm raising the question of awarding Mr. Ryazantsev the degree of Doctor of Doctoral Sciences in the scientific specialty 020009 High Energy Chemistry to an open roll call. I remind you that the decision of the Dissertation Council on the issue of awarding an academic degree is considered positive if more than half, but at least 3 members of the Dissertation Council who participated in the meeting voted for it, in accordance with clause 23 of the procedure. I will ask you in turns, and you will answer orally whether yes or no. Viktorov Alexey Ismailovich, your opinion? Yes, I agree. Vasin Alexey Vladimirovich? Andrei Vladimirovich, sorry. Yes. Bazarnova Yulia Genrikhovna. Yes. Skvartsov Alexei Nikolaevich. Yes. Tsiulianu Dmitry Ivanovich. Yes. And me as a chairman, I'm for the awarding the degree of the Doctor of Chemical Sciences to Mr. Ryazantsev. Thus, 6 voted for the degree, no one voted against, and no abstained. This is unanimous decision. Dear colleagues, due to the fact that our meeting is held with the participants in the remote access mode, do the members of the Dissertation Council or the applicant and others who are present have questions, comments, or on the procedure for holding the meeting? No questions or objections or remarks. Dear applicant, final words. Thank you very much. I would like, first of all, to thank the board members as well as my scientific advisor, who spent a lot of time on my dissertation. Not only now, these 2 hours hearing my dissertation. It is a very difficult and necessary activity to study dissertations and giving the reviews. And this activity is not paid. Thank you for the time spent on studying my dissertations. I would like to express my gratitude to those who taught me, to my colleagues. Thank you very much. That's all. Mikhail Nikolaevich, congratulations on awarding the academic degree of Doctor of Chemical Sciences. We wish you every success in the future. We see that your work is very promising in the near future. You mentioned that your postgraduate students will defend dissertations in the near future. Thank you very much. Thank you very much. The meeting is declared closed. Please switch off the live broadcast.